Hello students, I'm taking you to question number 27 by CBSE sample paper, new pattern. Well, this question is a very old question based on the properties of definite integration. Had it been that there is no x, अगर यहाँ x नहीं है, then one could easily divide by cos to the power 4 and we can proceed further. So how to remove x? For that, the limits are, if you can see limits, these are from 0 to pi by 2. So if we could apply 0 to a, then we can remove x and then it will be a simple question. So then most of the part can be done directly and then it will be a case of solving it through indefinite and then finally putting the limits. So why not to apply that? So we're coming up with the solution. So here's the solution. We can take the equation, the original question, as equation number 1, and by applying 0 to a, which is 0 to a f of a minus x, you can see that it will turn to 0 to pi by 2 minus x sine pi by 2 minus x cos pi by 2 minus x dx upon sine raised to power 4 pi by 2 minus x plus cos raised to power 4 pi by 2 minus x. And then what is sine 90 minus theta? So sine 90 minus theta is cos theta. So they will turn to cos. You can write also because it's a 6 marker. So you could write sine 90 minus theta is cos theta. And cos 90 minus theta is also sine theta. So they turn, sine turns to cos, cos turns to sine. That is, there is no effect because the product is commutative. But what we have is pi by 2 minus x. Also in the denominator, sine turns to cos, cos turns to sine, but raised to because of raised to power 4, and in the conversions are in the first quadrant, so it remains the same. So we have written this as equation number 2. The original question is equation number 1. So we add the two, adding first and second. Just see, by adding the two, what we get? We get x sine x cos x plus, from the second equation, pi by 2 minus x sine x cos x, and the LCM, because the denominator is same, the LCM is sine raised to power x plus cos raised to power x. And what is I plus I? That is 2i. Because of that, I'm writing it again. And I've opened the bracket also. This and this is gone. So pi by 2 is outside. And this is 2i. And now we can divide. Just see, we have created I, so we have divided by 2. So this is pi by 4, 0 to pi by 2 sine x cos x. And now this is a question which can also be taken into indefinite integration. And we are dividing each term by cos raised to power 4. So by dividing everything to cos raised to power 4, we get pi by 4, 0 to pi by 2. Now this is sine x over cos cube x, which is sine x by cos x is tan x, and 1 upon cos square x will turn to secant square x dx. And in the denominator, you can see that it is tan raised to power 4x plus 1. And can you see that, it's a very simple question? And now we can put tan square x is equal to t. Also changing the limits, It's infinity. The limit is infinity, because sometimes limits also, the upper limit and lower limit, can also be taken into open interval. Otherwise you could ask a question that why, because infinity is not a real number, so why are we taking infinity as the upper limit? So as I said, that infinity can also be taken into open interval. So that is possible in case of limits of definite integration. And what is the integration? The integration of 1 upon 1 plus t squared is tan inverse of t, and we can put the limits. Because it's a 6 marker, so you have to give presentation, otherwise you can skip few steps. Tan inverse of tan gets neutralized, so you can also write tan inverse of tan theta, which is equal to theta. So the answer is pi squared by 16. So it is very simple to concentrate. Initially we applied 0 to a, and then because of sine raised to power 4 and cos raised to power 4, we divided each term by cos to the power 4, and the answer is pi squared by 16. You can see that the answer is pi squared by 16. Thank you, or all the very best. Bye bye.